Hello, hello, hello. Welcome, everybody, to episode 3 of Shadow Agents. I'm Ryan Dennis, head of marketing at OpenServ. Today is not about anecdotes, it's about data. It's not about fake stage demos. It's about internal benchmarking, external benchmarking, and showing the real data, showing results. On scale multi challenge, that will be the word for the day. The same test that OpenAI uses for GPT-5. Thank you for joining us. And as always, our featured guest, host, and expert, CTO of OpenServ, Armağan. How are you doing today?
I'm very well, Ryan. How are you?
Outstanding. It's the best day ever, except it is also the anniversary of September 11th, which is also kind of the worst day ever if you're a native New Yorker like me. Both my parents were in Manhattan that day.
Oh, wow.
So, yeah.
Not
So,
sure, yeah.
prayers to
Yeah.
everybody who was affected by that. But on the eve of that, which was a attack on the American and the global financial ecosystem. We are trying to fix the global financial ecosystem here at OpenServ, as well as the industry of AI as a whole. Okay, we believe that Braid makes everything better and OpenServ makes all app building easier. So today we want to show real data, real proof of Braid, which is unbelievable. I can't believe these words are coming out of my mouth. Armand, what are we going to see today? And we'll let you get started.
First, I am beyond excited because, as we've been talking about this for the last two episodes, and there was a lot of buzz on Telegram about this as well, right? I told there as well that this is practically the work of my life. I don't think it would be bold enough to say this the work of my life. It's the culmination of everything that I've been working towards for the past, I don't know, 15 years. And yeah, today we're going to showcase what it means to work with Braid and the real performance gains, performance per dollar. There's a lot of different things that we're going to talk about today in evaluating large language models and their performances. So it's going to be partly extremely informative in giving a language to the viewers, to the audience to understand and talk about these topics, but also demonstrates in our internal benchmarks how Braid makes everything better, and especially the smaller, more affordable models, and how it makes them perform at the same level as the more expensive, 25 times more expensive models. And yeah, we're going to talk a lot about today.
Yeah, we have so much stuff to show you in store. We're getting prepared to go to Token 2049 for some big announcements in the beginning of October. So, welcome back to Shadow Agents. Let's get this started. Just as a recap for everybody, please subscribe, follow us and on X as well as LinkedIn and YouTube. In episode 1, we asked what agentic even means. What is N8N? Why it's a black hole. And in episode 2, we showed why fluency is not the same as agency. What does it mean to be agentic? And then remember that pie ordering demo from episode 2 where the agent forgot delivery time and the audience still applauded? It's funny in a bakery, but it's dangerous everywhere else. So today we're going to move from critique to proof and show you our internal benchmarking tool, the same results that we have already teased out to our very closely listening audience on Scale Multi Challenge, the same benchmark OpenAI uses for GPT-5. And benchmarks don't lie. And benchmarks are how we show that what we're building solves real billion-dollar problems. Whether you like it or not, we are going to fix this AI thing. While markets are noisy, this is where value gets created on the record, in data, in front of you. So take this, screenshot it, share it with your AI genius friend, and you won't be able to refute what you're about to see. Armand, are we ready to kick this off?
Yes, perfect. I don't even know where to start. Let's maybe start by talking about benchmarks, right? What benchmarks are, what specifically Scale Multi-Challenge is, and why what we're going to show today is very different than what other people do show, either on stage or on their demos. So benchmarking is the art of measuring performance of something. And in this case, we're talking about AI models. And it's very difficult to understand the performance of an AI model in a real world scenario. So for this, people come up with different challenges, questions for AI. And it first started with mathematical questions. Grade school math is the most popular benchmark of all time. And it quickly went beyond that, especially with tool calling, because you can give a calculator to an LLM, and it does a great job at solving those challenges. Now, then the second thing is, how do we make it closer to real life? And the benchmark that we're going to talk about today, Scale Multi-Challenge, is one such benchmark. It is practically following a multi-turn conversation between AI and a human being. I think it's not synthetically generated. I think it's a real benchmark. And obviously the AI responses are possibly like model generated, but the questions and the human responses are human generated, I believe. Now, what it does is the human comes up with a list of requirements in the first message. Say the very first question is, I'm working at UN headquarters and I'm hosting these world leaders, right? And they want to go to different places for lunch or for dinner. And I need really, really good places that are in 5-minute walk from where I am, with different categories. Security details, like, can you go there with security? Can you go there alone? What's the food like? What's the cuisine? And so on and so forth. And then, this is a huge list of requirements, very much like how we use ChatGPT, right? Like, show me the 10 top best places in Berlin is something I'm using all the time. And then the AI suggests certain things. And finally, the human hits back with a request. I need you to, like, these are my conditions right now. I need you to solve this for me based on all of the given information. And there are multiple challenges here. Like, does it really remember all the information? Can it use that information at all or in context? Can it generate new information? There are like multiple different categories of questions. And the goal here is, you give, in your benchmark, you give the question answer history, the chat history with LLM, and you ask your model to give you the next response. And that next response might be evaluated for the tone, for the correctness, for the like, can it remember, for its memory, and so on. And then obviously it's very easy for a human being to detect whether that's correct or not, that answer is satisfactory or not. But in a benchmark, you're supposed to run hundreds, if not thousands, of questions on tens of different combinations of models, which makes it impossible for human beings to evaluate. So what you do is you create another agent to evaluate the response of your model. So your model that is under experimentation, under the microscope, generates the response. Another agent that you write evaluates the response based on all of the history, which begs the question, how do you know that this agent is correct, that it's doing a good job in evaluation? So benchmarking is not a pure science with 100% correctness, because it's very difficult. We're trying to emulate human behavior and understand and run it at scale. Just today, just for this demo, I ran a benchmark I'm going to talk about in a little bit, and it gave me 9,000 different large language model calls.
Wow.
All of which are, either the benchmark itself, the questions, or the evaluations. So it's like, who is supposed to check all of those things, right? Like, it's impossible. But that's why companies only report numbers of benchmarks. Just like we did before, they're like, this is 50%, this is 60%. The code isn't open. The data set is probably open, but you don't know how they ran it. Did they do any preparation or anything? And you also don't see their individual results. You just see one number. And if you're following what I've been saying so far, the trick is, on every single run, you get a different result. Slightly different, maybe 1, 2, 3% different, but slightly different results. Now compare that to what Elon Musk said. Grok is like light years ahead, when it only had like 6% advantage over GPT-5 in one single task, and then was behind in all the other tasks. It becomes a very tricky business. But we've always been for transparency and, practically showing what we all have, because we have nothing to fear.
Exactly.
And that's why today we're going to show our internal benchmarking tool, which is not open source yet, and we hope to open source it later on, because it took a really long time to build that as well. This was an internal conversation that I had with you, but I guess we can recite it here. People really underestimate the amount of time any of these things take. Like, in order to create a software that can run 9,000 large language models calls in one go without any errors, and if it errors out, it should retry itself, it's very difficult. And it took me personally and a couple of my friends multiple days and weeks to get this piece of software to where it is. That's why you never see benchmarking software from large companies, because it's a piece of art. It's actually their IP, that their differentiator. If you can benchmark your models effectively, then you're also like very much ahead of the curve, because each benchmarking takes days.
That's a good point,
Now,
because Elon Musk shows benchmarks all the time. OpenAI, they're using benchmarks all the time, and they're using the benchmark that we're about to share, but they never show the tool that they use to test these benchmarks. So we're taking it a step
yeah.
further to show that. I just want to note that if the biggest names in the game are using this, then you should pay attention to what we're doing here.
Yeah. So it's also very important to notice that this end-to-end effort from like figuring out the benchmark, because there are hundreds of benchmarks out there, which one do you really pick? Which one best aligns with your challenges or what you're trying to show, to everything else, like gathering the numbers, making sure they're correct, making sure the cost estimations or the aggregation is correct, and showing that it's all working in one go is a giant task, but we're up for it. So today we're going to talk about our internal benchmarking tool, and maybe there might be a surprise at the end that we might share with our audience. And this is something that we've been doing for a long time, right? Like, we've been slowly revealing the curtain, or drawing the curtain and revealing what we're after. And we have so much in store that I'm literally not able to talk about right now due to NDAs and
I
certain
know.
things
I know, it's killing me. It's killing
that
me
we're
too.
trying to solve. But I want to show, if time allows, I want to show one of the most realistic use cases that's $1 billion business on its own, if not more, that practically plagues all e-commerce platforms and everything. Just to illustrate how Braid would be useful in a more like business context, in an area where you can really automate it with AI agents, where you would manually design the Braid architecture and put it to good use. So we'll probably talk about that a little bit at the very end. But yeah, now we can maybe start with
All right.
the internal benchmarking tool. I hope everything works. Live demos suck all the time, and
This is what it's about.
we're
This is
working
what it's
on.
about. So
We'll
bookmark
see.
this, and bookmark this time if you want to keep a copy of what it looks like when Armand is nervous. It's very rare. So let's share Armand's screen live and direct.
And here's the thing: no one does any of these things live, right? Like, you always see some pre-recorded videos, even if they're streamed. They are clearly pre-recorded and edited heavily. So we're
Yeah. Demos are vibes, right? And benchmarks are receipts. You can clap for a stage demo, but benchmarks force a model to actually reason. So we're going to show the tool, and this is I believe, our internal benchmarking dashboard, right?
Yes. So obviously, I'm not going to go through like the every step of the software, but what I can tease a little bit, is we have a data set selection, and I was talking about grade school math, and we have several other different benchmarks that we're running in the background, that we are internally reporting on and improving on. And in the coming days and weeks, we're going to be expanding the data sets. Again, each of these take multiple days. So please bear with us. It's not that straightforward. The scale multi-challenge benchmark that we're using consists of 273 questions. What no one will tell you is one of those questions, for some reason, is unsolvable. So, like, you never get a response from GPT. I don't know why. It just doesn't work. And that's why we dropped it. And then we picked randomly 100 questions out of those 272, just to illustrate a point, because again, this thing takes a very long time to run. And we control the randomness, so we always get the same set of questions every time we run this benchmark with the number 42. If we see 42 as a seed, it's always going to give us the same questions for like the first 100 questions in that set will be the same questions. So we can rerun the same benchmark over and over again to test its performance and to see, when you're making an improvement to the underlying architecture, you cannot test it on all of the questions, right? You test it with maybe 5 or 10 select questions, and you need to test it over and over again. So what we do is, like, this is why it's very crucial to have a fixed set of questions. And sorry.
And this is ChatGPT 5, not Timu or GPT 5, right? This is the OpenAI ChatGPT 5, right? Like the industry state of the art market leader right now.
Yes. A lot of people would disagree with that, but again, benchmarks don't lie. And the benchmark company that Elon Musk highlighted where Grok was better than GPT-5, which in turn turns out to be that GPT-5 is actually destroying Grok in every category. They are, how can I put it? Well, anyway, not very important. Let's talk about the models that we have. We're primarily working with GPT-5. It's the best model. Again, that's Elon Musk's company. I was trying to figure out the name because people would like to look them up, but maybe we can share it later on. They also say GPT-5 is the best, and benchmarks don't lie. So I can easily say GPT-5 performs the best in a selection of tasks. But it has many flavors, so let's talk about them. The GPT-5 that we're using in ChatGPT is GPT-5 minimal. I believe they also have a special mode for ChatGPT that completely disables reasoning, but in the API, you cannot disable reasoning. So even if it's there is a little bit of reasoning, and this is reasoning that we talked about in the first episode, right? Not real reasoning, but just words.
Yeah, this is the instant. I think it's the instant model on mobile that they use.
Right. So in the API, there's always a little bit of that thinking, that fake thinking going on. But the minimal model is what gives you the lowest amount of tokens, because tokens mean money. If you waste a lot of tokens, that means you pay a lot of money. So GPT-5 has several flavors. One is GPT-5, the default model. There is GPT-5 mini, which is a much smaller model, much cheaper. And there's GPT-5 Nano, which is 25 times cheaper than GPT-5, okay? But this is not the end. Every single model here, 5 mini, 5 nano, has 3 different reasoning effort levels. How much it's going to produce those junk reasoning text before it produces your answer. Ranges from minimal to, actually, I guess there's 4. Minimal to low to medium to high. High, I don't know what they were thinking. Maybe they were really high. Takes like 4 to 5 minutes for an answer.
Oh, goodness.
Like, you write anything, you write hello, and it takes 2 minutes. You write a sizable request, it takes 5 minutes to answer. So there is one part here in this benchmark that we haven't evaluated yet, which is kind of proxied by the number of tokens, and that is the time it takes to generate these responses, because that is one of the most important bits of this technology, right? We need fast responses. We cannot wait 5 minutes for a very simple question. But that's practically what GPT-5 High is. And so you see there are a lot of variations here. And in this specific benchmark, I picked GPT-5 Nano Medium, Nano Minimal, Mini Medium, Mini Minimal, and 5 Medium and 5 Minimal. Again, these minimal and medium ones are reasoning efforts, how much the model thinks. And then 5 Mini and Nano are model sizes, how capable it is in general. So it's very apparent, again, GPT-5 Nano is 25 times cheaper than the regular GPT-5. And the default in the API is GPT-5 medium level of thinking, reasoning.
And you said almost up to 40 times cheaper, right?
Yeah.
Wow.
And we're going to show a result
Crazy.
very similar to that today. But it's unbelievable. It's like I don't even know how to describe this. And the only thing that I can say is AI reasoning is a really hard challenge that all major providers are struggling with right now. They're trying to throw more compute at it. And I easily believe that GPT-5 actually costs 25, 50 times more than Nano to run.
Wow.
It requires special hardware. So it's not only a pricing gimmick. I think the actual costs are very similar to that. But as I'm going to show you next here in this chart, the performances don't really illustrate that point of difference in terms of cost. So let's zoom out a little bit and see what we're looking at. I believe this is very similar to the first ever benchmark result that we demonstrated. And what we see here is a layout of different results. Now, we have Braid and we have non-Braid versions, right? Braid is darker, non-Braid is lighter. So you can see in this 100 questions, GPT-5 Medium, which is the default API model, which is what you use with ChatGPT in thinking mode, I think, performs measly at 58%. And with Braids, we take it to 62%, which is, not bad. But one tough challenge of this benchmark is that it's so human, and it's a multi-turn conversation, and some of those conversations take a different turn. So it's very tricky for AI to reason about. But what is important here is what we see here, GPT-5 Nano Medium. So this column is GPT-5 Nano Medium, all right? This purple you see here, GPT-5 Nano Medium. This also performs at 58% with Braid, which is basically the same performance of GPT-5 Medium. And again, the price difference is at least 25x because GPT-5 produces more tokens when it's thinking.
Wow.
And the weird thing is you're going to see like GPT Nano Medium is at 46% performance. This generates a lot of tokens. GPT-5 Nano Minimal, which produces minimal thinking tokens, is also at 46%. This is why I think this is a very good benchmark. It destroys your AI reasoning. Again, this is OpenAI reasoning. GPT-5 Nano Minimal to Medium performs the same. It's spending thousands more tokens, the same model GPT-5 Nano, But from minimal to medium thinking effort, there's no performance change, even though you spend maybe 5-10 times more money. Okay. And if you look at Braid, it gives you a 6% difference in nano minimal, which is, again, worthy enough for it to beat from Elon Musk. And that outperforms the nano medium at a fraction of the cost, because this is generating minimal tokens. This is generating a lot of tokens, thousands of tokens.
So this is what we'll be able to see in action. Like, because here, the problem is that GPT-5 nano models perform the same 46%, whether they use minimal or medium thinking tokens, meaning the expensive thinking process isn't actually improving results. It's just burning through more tokens without better outcomes.
Yeah, and slowing the response, basically. Like, this returns in 5 seconds or so, nano minimal. Nano medium returns in 10, 15 seconds.
Okay. So in what you'll show us today, hopefully, and in future demos as well, GPT-5 Nano Medium with Braid achieves 58% performance, matching GPT-5 Medium's performance, but at 25 times lower cost, since it's using fewer of those thinking tokens, right?
Right.
Cool. Amazing.
That's
it's kind of like, I don't know. I don't know how to put into context 25 times cheaper, or up to 40 times cheaper in any other sort of like analogy. So I think people would love to see this at work and in action.
Right. And here's the thing, just for the developers out there. In real life, we have a tendency to believe what we want to believe. That's why benchmarks are very useful. And you see, take GPT-5 Nano Minimal, 46%. Take, sorry, GPT-5 Medium, 58%. The difference, there's a difference, but is it worth 50, 60 times the price? So what everyone is trying to do right now is to downgrade from GPT-5 to GPT-5 Mini or Nano, because they can take this performance hit. Most of the times, your AI application doesn't have to be 100% correct, right? So they take this 10, 12% performance hit and make it way cheaper. And that's why Braid is very useful, because you're giving away your accuracy budget and we're putting it back into your minimal models.
Okay, so currently we're presenting some bar charts. I think we want to give some of our audience members, because we do have some questions in the chat too.
All right.
We need some indication on how we came to these results. Like, what is happening in this benchmark process that gave us these results? I know you gave us some at the beginning, but if you could break it down.
I'm gonna talk about that. So a lot of different charts that we use in performance measurements, number of tokens that are used per model. It's very detailed. I don't really want to waste more time here, but what I can show you is here. Costs.
Wow, a lot of disparity here.
Yeah. So GPT-5 Medium, these are our raw costs for running this benchmark. It spends, and it's roughly the same performance, right? Like 10%, 12% performance increase. It spends $27 versus 30 cents for GPT-5 Nano Minimal. So whatever you can put here to make it closer to the performance of GPT-5 Medium, you're going to win. You're going to win really big. And we also show, in order to kind of like neutralize this chart, we show performance per dollar, because these models charge different amounts of money, right? We need to equalize them to see them at eye level. And it's an arbitrary y-axis, but what you see here is nano medium and nano minimal are practically giving the same performance per dollar. And that number, if we zoom in here a little bit, is 105, okay, versus 3.38 for GPT-5 medium. So the performance gain or the cost reduction for the same performance, because this is performance per dollar. How much performance do you get for $1? Is, I guess, 30 times. Let's do the math. 31.25 times.
Wow.
Performance per dollar.
And it's quite unbelievable.
Yeah. It's a little bit believable for me because I've been working with this for
right. But for the rest of us, you know, because we have a question in the chat here. Is it 25 times cheaper for every question, or only for the questions where a lot of thinking is needed?
No, for every question. It's bare model cost. And again, by tweaking the thinking budget, you can actually take it up to 40x, 50x. And here we see like this is just the average. Like there's disclaimer, no pre-processing in this data, no post-processing. This is just a raw benchmark that we ran with Braid. And I'm actually going to give you another tip on how we achieve these results. Because in theory, this could be taken further. This 31.25 times performance gain could easily be increased to 40 or maybe 50 when humans are a little bit more involved. Don't forget, I told in the very beginning that this is all machine generated, right? Now in the next section, I'm gonna talk a little bit more about Braid and how it actually works. And there I'm gonna make this distinction. But this is all machines talking to machines to generate this performance numbers. If you involve human brains in Braid, you can easily take this to 50x or more, which is something that we already do in production. But again, it's impossible to put human brain for 9,000 combinations, right? Yeah. That's why we're trusting the machine to do this. But yeah, I think this is the most direct chart that shows us the very raw, without any optimizations or anything, very raw, very simple performance gains for GPT-5 Nano Medium and GPT-5 Medium. And actually, please go ahead.
Go ahead.
I was going to say, like, if you look at it, Nano Minimal is practically the same with Nano Medium. So Nano Minimal, obviously no chart is perfect, right? Like this is not showing you how many tokens it's generating, so how long the answer takes. But Nano Minimal is way faster than Nano Medium. So even though Nano Minimal would give you less accuracy, it would give you the same performance per dollar, basically.
Got it. And when you say performance, I want our audience to understand what you mean when you say performance per dollar, because I know that when you, like in the breakdown here, I guess just to reiterate and try to make sure I got it right, GPT-5 Medium costs, let's say $27 to run the benchmark versus 30 cents for GPT-5 Nano Minimal. So that's 90 times more expensive for only 10 or 12% better performance. You'd think you'd get 90 times better performance, but instead you're getting basically a tip on top of your order. So when you calculate how much performance you get per dollar spent, the nano models are giving like 30, 31 times better value than GPT-5 Medium. But what do you mean when you say performance? What's being performed? Is it a great answer?
It's the accuracy. Because obviously all of these benchmarks come with the expected answers. So even if you require evaluation, you need to know the correct answer that you're gonna get at the end. And it's usually either a number, so you can directly match, or a yes or no, or a multi choice question. So you have like 5 different choices to make. So there's always a definitive answer to these questions. That's also how we measure accuracy here in this chart. And that's what we're using in this calculation. to calculate the performance per dollar. Practically, if you spend $1 with GPT-5 medium or GPT-5 nano minimal, how many number of accurate responses do you get? Does that make sense?
Yes. Well, I mean,
Spend
because the only
$1
reason you
AI.
prompt is the only reason you prompt an AI is to get an accurate answer, not a pretty good
Right.
one, but an accurate one.
Right. So we're trying to basically like how many accurate answers we can buy with a single dollar if we use different models.
Got it.
All right.
We
Now,
got another question here, I think, and then we can
right.
continue in the next section. Is Braid essentially prompt engineering so model stays within outlined limits?
So prompt engineering is a very loaded term, right? It's so loaded that people came up with a different name for it, context engineering, which is essentially the same thing. Chain of thought is also prompt engineering or context engineering. So I don't think anyone would like to use that term. I also don't like to use that because Braid is very much like chain of thought, an architecture where you shape your thoughts and present that to the large language model. Obviously, the only way you can communicate with the large language model is by giving it system prompts. So you're working with the prompt, yes. And it's not at the model level. It's working at the prompt level. But I wouldn't necessarily call it prompt engineering. It's practically an architecture for you to think how you're going to shape that prompt, how you're going to talk to a large language model. And I'm going to show you examples now, and it's going to be even clearer what I mean by that, because we're not going to be talking English to these models. Or
No English. How are we gonna? How do we do machine learning without English? We need English. At least I do. I know you know a couple of languages.
So humans do need English. Apparently, large language models work better with different languages. And we're going to be showcasing one that is mingled with English that improves the performance of these models, and why it's very difficult to really calculate the performance, and why we're always taking the lowest estimates just to make sure we're giving a correct number, and why real world performance will actually be better, and why we see it differently in real life. Okay, now, so let me show you what we have here as well is a detailed breakdown of all the questions in the benchmark and how each model performed under each question. So these are the different combinations. Let me show you one example. Unfortunately, I am not showing you the actual question here, but we can see what the answer, the generated answer was. Apparently, this is a request for like a buying advice on computers, right? That's what we can see here. And the judge then decides whether this answer meets the criteria, whether the verdict is correct, yes or no. And in this example, in this generated answer, this is what the final answer the person would see. Okay. But this answer is generated via Braid. Whereas this answer over here is just a regular large language model call to, in this case, GPT-5 mini medium.
So you just
This is
showed
where the
green is with Braid and red is without Braid.
no, this is red because it's wrong. Like the judge believes that this is not meeting the original criteria.
Got it.
And again, this is scale multi-challenge benchmark. It's open. Everyone can look at these questions and see what the question actually is, what the the chat is and what the evaluation criteria is, basically. So apparently the judge liked our response better than what the default GPT-5 mini medium gave. There's very minimal prompting here. I can show you, like, these are all the different questions. That's like practically 100 question that we are evaluating. And if both
How long
are...
does it take to go through this?
You mean to run it?
Yes.
Depends on how much compute you'd like to spend. This is also why I didn't do the entire benchmark, because it can easily take like 8 hours with just 6 combinations. If you apply all the models, it's probably going to take 1 or 2 days. If you apply more compute, you can bring it down to maybe 3-4 hours, but it's definitely going to run for that long.
Okay, so anybody asking why we're not showing the full benchmarking demo, it's because if I stream for 1 to 2 days or not, I'll lose custody of my children. So
yeah. So here's the thing. Like, again, if both are green, it means both approaches gave the right answer. Like the classic approach has the right answer. The Braid approach has the right answer as well. And then you see the classic approach fails, and then the Braid one wins. But actually, let me show you an example of how this is generated.
yeah, because I'd love to see more of the back end, like the guts, to show people that this isn't just a dashboard that you spinned up for this showcase.
Right. So it's very... I don't know if I'm going to be able to zoom into this. No.
Wow, that's some fine print.
Yeah. Is it here? I think it's... Is it this one? Yeah, I think it's this one. Yeah, talking about iPads and stuff. So I already prepared a more readable version of this. So what we do here is...
Wow. The mermaid code, live and direct for everyone to see. Take screenshots, folks.
Now I'm going to dive into how Braid actually works, I guess, for the very first time. So please pay attention. You have a question to answer, right? It could be anything your AI agents are trying to do. And it's giving you the wrong answer because there's a lot of things in its set to calculate, a lot of different criteria to meet, and it's not doing a good job. One of the main reasons for that is because your system prompt looks like this. It's just a body of text. And if you remember what we discussed about large language models and English, this is a linear text, but you see almost every line has an if statement. And for programmers out there and for the aspiring engineers, ifs mean branches, conditionals, because it could be either this or that, or maybe, it could be multiple if statements as well. Maybe 5 different outcomes could be the right answer. It's very difficult to go through this, okay? So large language models work by assigning an attention, let's say, coefficient to every word to generate the next word. And there's a lot of words here. This is why, if you noticed in our, I guess it was live, in one of our recent tweets, we talked about signal to noise ratio. If it's not live yet, it's going to be live, hopefully in a couple of days. It was something the marketing team was working on, and I'm really unsure. But there's a lot of noise here. Like, this is noise. We don't need it. There are a lot of noise words here. And the idea is you can actually strip them away, but you need to replace them with something that the large language models could easily follow to reason, because they like directness. And normally what happens is a human engineer takes the system prompt, which is possibly written by a human being, right? From maybe a sorry, someone from marketing or product wrote this, or maybe if you're a startup, a founder wrote the system prompt in ChatGPT and they say, this is working for me, right? An engineer takes this, reads this through, and converts it in a format that the large language models could understand better. And that presents itself as this syntax over here. We could pick any, but we picked the syntax called mermaid. I wish I could drag my browser. Oh, wow, it's froze. Okay. Which is this one over here. That wall of text practically is represented by this. Because for humans, it's very difficult to understand what this means. S1 to P, S2 to P. What is P? It's very difficult, right? But for machines, it's very easy. For large language models, it's super easy to follow this. It's actually much easier than English. Does that make sense?
It sounds like machine native language leading to machine native reasoning.
Exactly. So here, I'm not going to go into the details. People can look this up online. What we are doing is, in fact, generating, if I could zoom out, generating something very human. This is called a flowchart. Does that make sense?
Yep.
You see a flow.
These are decisions it's making. If not this, then that.
Yeah. You know, if there are explicit sentiment words about love, perfect, recommend examples, it's positive sentiment. Could be mixed or unclear, you know. And this is a flowchart that tells you how to decide, which is something that's in every single operation handbook, whether it's a call center or, I don't know, international law. It's practically everything is a flowchart. Everything is a process. This is modeling a process of decision making, which is something a human being is trying to put into words here, right?
Yeah.
It's very difficult to follow.
Yeah, I think the problem with traditional, or I guess you could say linear text, is the prompts that we make, they have multiple branching conditions all mixed together in English paragraph form. It's difficult for AI models to translate it and to give proper attention to the points we want to give attention to. And instead of processing what is kind of like a wall of text with embedded conditionals and context and sarcasm, the AI here can follow a clear decision tree because of Braid.
Exactly. Here's the thing. Just a random sentence that I pick. Increase sentiment by 1 level. What does that mean? What level was the sentiment? It's assigning certain sentiments here, positive, neutral, negative. And then what? 3, 4 paragraphs later or bullet points later, it's asking to change it. So you assign something and then you change it. Obviously, it's very difficult for large language models to follow this.
Yeah.
Because there's
especially at scale, right?
Yeah. This is a very basic but impactful example. We can come back to this later on. I just wanted to explicitly show you how these things work. And here, what we do is we generate, sorry, based on the question, we generate a flowchart on the fly that will act as the backbone of Braid decision making. This is why, by the way, we call it bounded reasoning, because we have constraints, we have specific steps to follow, right? So it's not really like it's impossible, almost impossible, let's say. No one can be 100% sure about AI. It's almost impossible for a large language model to go out of its way when you tell it to follow these steps exactly. And Do you know
So
why?
it's not gonna get distracted. It's gonna stay focused.
Yeah.
Stay focused
Yes. And do you know why?
to save resources.
No. Like, how does it do that? How does it
Oh,
stay focused?
I don't know how it does that. I'm just a fly in the wall.
It's because the steps and the step
Ah,
transitions are this simple.
the decision
From
tree.
Yeah, from S1 to P, from S2 to P, from S3 to
Ah,
P.
wow.
It's this simple. Whereas, here, I don't know. It's a mess.
Okay, so I have to ask because this is exactly what we talked about last week with episode 2. Or tune in if you missed that, and the messed up bakery order. Um, I'm sure OpenAI is shilling their voice agent and to enterprise clients. And I'm
Right.
curious from you, if are there any sort of real clients already piloting this, curious about Braid? The people want to know, is there anything
So
on the way?
what I can tell, because I hold the IP on that one,
Put you on the
the,
spot with your IP there too.
the very first company that tried out benefited from Braid was I guess they're the largest white goods producer in the world. They use it for their call centers. They piloted
Wow.
it, let's say, for their call centers to call practically like hundreds of thousands of people a day for warranty upselling.
Okay.
And
Wow.
uh, that was like the very first step of Braid. And
Wow.
that's why you can understand that's why the OpenAI demo of phone calling is very near and dear to my heart, because that's practically the problem that I solved with Braid.
I mean, that's mind blowing to think that there's already a pilot happening
Yeah.
with the
And
largest call center provider
well,
in the world.
I can tell you, they're probably not the largest call center provider, but they're the largest white goods producer. And there are, again, still in the talks. I'm not able to tell you. Possibly in the next next 1 or 2 episodes, we're going to be able to talk more about it.
Stay tuned.
Braid is already in production for very large enterprise contracts, and like Braid as a technology, as an approach, as an architecture, is already powering real decisions that cost real money, and that humans would still like to defer to AI and wouldn't be able to do otherwise. This is why we're so ahead in this research. We're not only theoretically figuring out the best ways of finding the syntax, because like this is called Mermaid. There are tons of other languages like this, like PlantUML is actually my favorite language for flowcharts and for architectural documents. Why are we not using that? This all is based on experimentation and research. And if you don't have real life feedback, obviously it's all academic and doesn't really make sense or get you anywhere. And this is why we're so, I could say, maybe bold with Braid. We're already, powering some real decisions, very hard decisions in the world. So I hope we're going to be able to talk about them in a couple of weeks.
That's right. Everybody has to subscribe and
Right.
stay tuned.
Right. Let's go back. So, again, this is internal tooling, right? Like we have a very tiny, very tiny rendering of the same decision-making tree here, practically the same tree that we see here. But this is how we benchmark Braid. And what I can tell you is that this benchmark isn't doing justice to this technology, because again, in order to be benchmark agnostic, there is zero prompting outside of this this code, what we're shipping to a large language model. Because in the classic version, we're saying you're given this chat history, respond. That is as bare as we can get for bare performance. And here we say, you're getting this chat history, please respond with this process. That's all we're saying. 0 customization per question, which is obviously how this doesn't work in real life, right? In real life, first of all, this is written by a human being and not by a machine. And a human engineer optimizes every single word out of this. This is why industrial engineering is also going to be on the rise, I think, because this is process mapping, process engineering. You need to figure out the exact process to decide in that, like for that specific query. In real life, maybe in an AI application, you have 10, 30, 40 different concerns. And most applications are like 5 or 10 different concerns that you have to build this syntax for. Wow. So you can afford to do that with humans. And again, here we have, for example, 100 questions, and we're running it over and over again. It's impossible to do this by hand. That is why we are doing a combinatorial logic here to generate this diagram, this flowchart with every single model, and then every single other model is testing that to create the response. This is why there are so many bar charts here, like bars here in this chart. You can see this is like showing us the generation and solving combinations. If we look at, I guess this is the highest performer here at 63%. The syntax here is generated by GPT-5 Medium, and it's run on GPT-5 Mini Medium, which is, I don't know, maybe the price difference is 10 times or 15 times. I'm not sure. If people know, they can let us know in the comments. You can look it up on OpenAI, basically. The difference between GPT-5 Mini and GPT-5. And here's why it's significant. First, in real life, there is no generation model. It's only solving model because you're writing it by hand, right? Which is very optimized. But even if you're generating it with a smarter model, you're generating it once per type of problem because it's an approach. It's a process to solve problems. And usually you have buckets of problems. Like if you're an HR company, you might have CV evaluation is a bucket, right? You're not writing a new process for each CV. You have that process once, you encode that, and then you run tens of thousands of CVs through it, which means the solving model is way more important to be a smaller model. If you can solve, like, again, this is the highest performing in this result. GPT-5 Mini is the highest performer. And we can also see the Nano here, which is also doing very well. Nano Medium. In real life, there's no cost to generating this syntax of the decision tree. In real life, there's only solving is the term that we're using. You're giving it, the model, a flowchart, and it's solving that for you. That's the cost that you're going to run. That's why I'm saying it's actually way cheaper, like more cheaper than 25x or 30x that we're showing here. Because here, of course, the generation costs are also included because we have to do this at scale. Machine is generating this per question. Do I make sense?
So, yeah, because it's funny because there are so many models, and I'm wondering how many models we wouldn't have even need to have seen be invented or created, because you can here get the same AI performance for 25 to 50 times. I thought it was 40, but now I'm seeing 50 times less money by using cheaper models with Braid instead of expensive quote unquote thinking models, which carry the
Right.
illusion of thinking. And the cheaper
Right.
models with Braid often outperform the expensive models that take 3 times longer to respond. And I'm sorry, but if I'm talking to a call center or if HR is going to give me an answer, I can't wait 3 times longer on a phone call
Right.
with AI.
Right. Of course. So that's why it's crucial to use the minimal models and everything that you can do to push this number higher. Um, so the goal here is very clear. We want to push the boundaries of what AI can do. And I guess 2 years ago, I gave a talk and I was saying, or maybe like whenever GPT-4 came out first, like the first time it came out, I gave a conference talk, and I said, to everyone's surprise, we're barely scratching the surface of what these models can do. There's so much inherent power and performance in these models, and Braid is one way of releasing that, basically, if that makes sense.
Wow. Okay. Well, I'm excited to see this rolled out across OpenServ's platform and helping millions of people across the world working across industries, call centers, healthcare, insurance, education. I can think of property management, supply chain. It
Right.
just kind of democratizes AI, kind of makes advanced AI capabilities affordable for businesses that couldn't justify expensive model costs before. We've seen tons and tons of these companies. So can you, in one sentence, just share with our audience how is Braid Tech unique?
Uh, it's unique in its understanding of, or let's say in its origin. It's not coming from a point of view of apply more compute power to get better performance, but more like, let's take another look at how these large language models work and figure out, engineer a better way of drawing more performance from them, which is, very easily exemplified here
Insane. So,
in
so
performance per dollar.
how is this unique from everything else on the market? Because I'm sure everybody in our audience, just as much as you and I, sees new AI claims
Right.
and products every day on X and the news. How is this unique from everything else that we might be seeing?
Um, it's very simple. Pretty much all of the industry, including foundational model creators like OpenAI, Anthropic, Google, and other technologies, which I don't want to name, some of them are competitors, are working on AI reasoning to practically create this.
Yeah.
So everyone's minds are creating a better version of this. Maybe the goal is the human writes this, right? Like the human is writing this, and that AI tool is trying to convert it to this other thing, which is something that you could write. And they believe by doing this, they're going to improve the performance of these models. This is why, again, we have all of these thinking models. They're producing thinking as, I guess this is called prose in English, right? Just like wall of text, which is not helping the large language models at all. If you have a way to represent your process, because reasoning is a process. Reasoning is not a blog post, it's not a write-up, it's a process. So you need a way, a language to visualize that process, to make the underlying models understand that process. And if you have such a language, you perform much better. And this is how Braid is different. We're using a different language to
Mm.
visualize this process, or to help large language models understand our process better. We're using a language that they understand better
Wow.
than
Okay.
English.
A new language. It's time for you to get a what is it? A Duolingo for AI, because Braid is a new language for AI. We're talking about machine native reasoning,
Right.
machine native language, and what we've seen today. It's not just impressive benchmarks, right? I mean, essentially, this is a new moment because it's a shift in how we should think about AI efficiency. Because everyone else is building bigger, more expensive models, but Braid proves we can get better results from cheaper models by simply speaking their native language. And this is important in emerging countries, emerging markets, and emerging economies. The fact that this is already powering real language is incredible.
There's one more thing. It's also valuable for local LLMs, right? Because people in their phones want to be able to run models, but their hardware is not capable enough.
Right.
So they cannot run huge models. They need tiny models to run on their machines. And that's why if you can improve the performance of a tiny model, then it's like day and night difference. Like you can create new economies out of this.
Yeah,
And that's where we're at.
that's incredible. Well, I think instead of asking, how do we make AI think more like humans, be more like me, Braid asks, well, how do we help AI think better as machines? That's what they are.
Right.
So be yourself, AI. This 25 to 50 times cost reduction. It's not just saving money, it's about making advanced AI accessible to every business that's been priced out of this huge moment of AI. And that's a billion person problems being solved right there. So this could be the tech that finally bridges that gap between AI hype and real world utility. We can actually put this into action everywhere. I don't see why not. So that this is, I mean, listen, we charged you with a demo. Show us the guts of Braid. Show us the back end. Is this real? Is this vaporware? Okay. Anybody who knows me knows that my first job in Web3 was actually calling out crypto scams. Okay, and I also proved that Tron wasn't a scam in 2019. And so now what I've seen here is, I mean, this is just the most jaw-dropping experience. I can't believe what I've just seen, and what I'm hearing about the people who are getting involved and trying to get their hands on this tech. We're excited as well. So season one and episode 3 of Shadow Agents. Getting ahead of myself. See how excited I am? Is now under wraps. What should we expect for episode 4? What's coming next week?
It's a very good question. I guess we can also ask for some ideas on the Telegram chat, because obviously their messages are fueling us, right? And we could go more into theory, we could go more into application, we could talk about different use cases. It's very difficult because Braid is solving real world problems and is geared towards solving real world problems. It's very difficult to come up with like hypothetical questions, but real challenges like that call center thing. Maybe we can do a demo of how that conversation could work like with Braid, because obviously I did that way before OpenAI did. And we could, like, I could call you, or you could call my AI agent, and you could have a conversation with it. Maybe we can demo that and see how that conversation would have worked better with Braid. Even though, again, like, we're not trying to badmouth OpenAI. Like, it was just a demo that they showcased, but it's underlining a very big problem in AI reasoning, and it's just a good example. It's what Braid is solving. So yeah, we could do several different things, and this is a very good decision problem as well. Maybe we should apply Braid to
Exactly. How to take this on to the next level. Let's go a lightning round with some of the questions in the chat that we did miss. There aren't too many. So is Braid essentially taking a user's yucky prompt, cleaning it up, and making it easier for the LLM to understand and act? If you could give us a succinct answer.
So yes and no. No, because Braid gives you, the engineers, the framework, the tool, the language to speak to AI. Like there are horse whisperers and dog whisperers and like people who are very, very close to animals. Animals always listen to them and you cannot. Like they don't listen to you, however hard you try. It's very much like that. Braid is that approach. We're going to be teaching how to make best use of it to engineers in the coming months as well. But it's practically teaching us how to talk to these language models. However, there could be a product which we also may or may not be working on to take a user's yucky prompt, cleaning it up, put it in the shape of Braid, and sorry, put it in the shape of Braid and give the user a choice to improve if they like, or a choice to apply it right away. It's very easy. That's practically the approach that we're doing in the benchmark. So our approach in the benchmark is literally taking a yucky benchmark question, comes up with a solution to that in Braid, and that makes it easier for the LLM to act in the most accurate way.
Beautiful. And somebody else asked, maybe we can show this next week. What's your favorite decision-making tree?
I don't know. Maybe it's like love at first sight. I'm never gonna get over call center prompts anymore.
Everybody loves talking to the call center. It's always a good time.
And it's a recurring theme. I'm gonna tell this story next week. My work with call centers actually started 13 years ago, 12 years ago. So I've been building solutions for them for a very, very long time.
Wow.
And yeah, it's crazy. I cannot get rid of call centers.
If OpenServ fixes call centers, then I'll have truly made my family proud. And the last question here, is Braid proprietary? What's IP protected? I think people want to know about the moat behind behind Braid and OpenServ here.
So I guess we answered this a couple of times on Telegram.
Yeah.
I believe we can create billions of dollars of opportunities for everyone in the world if we open source this, if we tell it in our papers exactly how we do it. But of course, products, like think of Braid as the next thinking approach that all of these agents could inherit. All of the OpenAI, Anthropic, whatever. They could all, in fact, I'm not sure if I am allowed to say that. I had a call with a very large provider this week for some AI cooperation. I think I'm just allowed to say this much. To get their interest in our paper, our upcoming paper. We believe everyone will benefit from this technology, just like how they benefit largely from thinking, from reasoning models today. But of course, how you do that in your own platform is the actual IP. So as the originators of Braid, we know how best to make use of this technology. And we know how to bring it to the market, to different products. We're obviously the first in the market since it's our own technology. And everything, the ecosystem that we're going to build around it, and we're already, like, that's already in the works. Braid is great on its own, and you can easily show that in benchmarks, but in real life projects with different agents, different architectures, I don't want to give away our IP, it shines even more. Some people will see that when we go mainnet, there's literally going to be a visualization of Braid in action, which is super exciting. And maybe you're going to understand a little bit more what it means to create an ecosystem around Braid. But that is where our IP is, how we use this technology. Because Just like any technology, this could be great in good hands, also disastrous in bad hands, and
Yep.
that's our mode.
So I have to say, after years of AI promises that don't deliver, seeing Braid actually solve the fundamental problems like that OpenAI bakery disaster while making it 50 times more affordable is incredible. And you know, this is how you change the world, not with a bigger model, more
Yeah,
spend, but with smarter architecture, more clever. And I think what the people want is, can we see a head to head? I think everybody wants the head to head. They want to see Braid.
that is the head-to-head.
What's that?
Like, we literally spent an hour looking into head-to-head differences between GPT-5 models and Braid in the benchmarks. But yeah, maybe again next week we can do different demos and talk more about it. There's always one more thing, right? And we have a lot more in store for Braid's future. That's going to be proprietary. If you think about it, everyone is doing reasoning, and you see Gemini thinking, Grok thinking, OpenAI thinking, right? But they don't really reveal what they're thinking to you. They reveal only an excerpt, because how they think is their moat. So for that, we have really big things in store for Braid as well. How we approach this is our moat, and everyone will benefit from the competition, just like the foundational models. They're all thinking right now, and the father of that is a single paper, Chain of Thought, which practically says think step by step. That's the entire thing. And all these companies take that to the next level and have their own flavors of chain of thought, or how those models think. And obviously we have our own with Braid.
Amazing. Somebody asked when mainnet. All I can say is, listen, imagine all this on chain. Okay. There's a big set of announcements coming. You have to stay tuned. You have to be patient. Okay. This is real technology. It's not McDonald's. Okay. This is gourmet architecture we're fixing for you guys. So stay tuned. Subscribe to our YouTube. Follow us on LinkedIn, on X, and definitely follow Armand. Okay. If you like these big brain conversations, he's starting to drop more and more dimes on the X. You're getting good there. I appreciate it. So thank you everybody for your time. And thank you, Armand, for proving Braid in real time, live and direct. Everybody, please have the best day ever and enjoy, and stay tuned for episode 4 of Shadow